All right, let's get those labels on the bags. We'll be using the robot's force control for precision. Follow me to the training room and I'll show you how force control works. One of the robot's key safety features is its ability to stop automatically if it collides with something or applies too much force. However, for certain tasks, like applying pressure to make a label stick, the robot needs to use controlled force. To achieve this, we use the force control feature. Let's test it out by navigating to the Templates menu in the left pane. And then insert a force node into your program tree. Here, in the simple mode, the robot will push down with the specific force along the z-axis of the base feature. Go ahead and set the force to 2 newtons. Press the Test button now, and push the 3PE switch to the light press position. Now the robot applies a force of 2 newtons at the TCP in the positive direction of the base z-axis. Now, let's switch the feature to Tool and test it again. Hit the Test button once more, and press the 3PE switch again. This time, the force is applied at the TCP in the Tool feature's positive z direction. You've just seen simple force functionality in action. Ready for something more complex? Let's explore the frame functionality next. Select Frame from the drop-down menu. Frame mode lets you customize force on each axis and even control rotational forces or torques around them. Torque in robotics is similar to how you use your hand to turn a doorknob or tighten a screwdriver. It's the force that causes something to rotate, so torque is used if you need to control precisely how much twisting force the robot applies. We'll use the base feature to apply force along the negative x-axis, and to apply torque around the x-axis at the same time. Select the base feature, and tick the x-axis checkbox. To apply force in the negative direction of an axis, simply enter a negative value. Set the force to -2 newtons. Good. Then tick the RX checkbox to add a torque around the x-axis, and set the torque to -2 newton meters. This configuration applies force in the negative direction of the x-axis and a rotational force around the x-axis at the same time. Let's see it in action by clicking Test. And press the 3PE switch. Great! Now let's apply what you've learned to actually placing a label on a bag using this force control. The labeling station setup includes a label dispenser and a conveyor managed by the labeling robot. We've also got sensors to detect when a bag is ready for labeling and when it's ready to move to the pallet. Let's dive into the programming. I've already set up some initial commands for you. First, I added a script command to let the robot at the pick station know that this robot is ready to receive a bag. Next, there's a folder containing commands to pick the label from the label dispenser, and a folder for the sequence to place the label on the bag. First, we wait for the bag to arrive on the conveyor. Then a script command lets the other robot know we're busy with labeling and not ready to receive another bag. Let's start programming the label placement. The first step is to move the robot downward onto the bag using a direction command from the basic menu on the left. This direction command will continue moving the robot until it meets a specific condition. Perfect for our needs since the bag heights might vary. Now to find the TCP movement direction. Select the base feature. Select the negative z direction to move towards the bag. Next up, let's define when to stop the movement. click the Until node in the program tree. Choose the Tool Contact option to stop the robot when it touches something. This makes the TCP move down until it detects contact with the bag. Now, when the label touches the bag, we need to make sure it sticks. Click Add Action. Navigate to the Templates menu on the left and select Force. We'll apply force in the positive direction of the tool feature's Z-axis. Select Tool in the feature dropdown. And set the force to 2 newtons. Good. Now, when you use this force command, any subsequent commands will automatically maintain a force of 2 newtons in the tool's Z direction. Select the empty node below the force command to insert a command that, for our current task, we need to apply this force briefly. So let's go ahead and add a wait command from the basic menu to control the duration, and set the wait time to 2 seconds. The robot now applies a consistent force for 2 seconds. Next, we'll add a Move L command to move the robot a little bit up from the bag. Since we don't know the exact location of the TCP due to the direction move we used, we'll use a relative waypoint. Select Relative Position in the drop-down menu. Using a relative waypoint means we're setting the robot's position based on a distance and direction from where it currently is, instead of a fixed spot. Go ahead and click the first Set Point button to start defining this movement. Now, let's set the starting point for our movement. This will be the robot's current location. Just click OK to confirm this as our starting position. Next up, let's define how far and in which direction the robot should move. Click the Set Point button again to specify the endpoint for this movement. Activate the free drive to proceed. And move the tool a bit upwards to the left. Click OK to save this as the endpoint for our movement. Looks like the label isn't fully sticking. Let's smooth it out using a direction command combined with force. Head over to the template menu on the left to get started. And hit the Force button. For this task, we need a more versatile force mode. Go ahead and select Frame from the drop-down menu to adjust our force application more precisely. We're going to move the TCP in the negative X direction of the base feature while simultaneously applying force to the label. Select the Z-axis to set up the force direction. To apply force downward along the negative Z-axis, we need to set a negative value. Adjust the force setting to -2 newtons. Next, we'll apply torque or rotational force in the clockwise or positive direction around the Y-axis to make sure the tool uses its edge to smooth the surface. Select the RY checkbox. Set the torque to 1. Good. Now let's proceed by adding the motion to which this force and torque will be applied. Select the empty node below the force command. And insert a direction command from the basic menu. Now, set the robot to move along the negative X-axis of the base feature. In the direction menu, select X- to configure this movement. Next, select the Until node in the program tree to set the condition for stopping this movement. Let's set the robot to move a specific distance. Choose Distance from the options to configure how far it should travel. Set the distance to 250 millimeters. All right, let's add a couple more waypoints, and then we'll run the sequence to see how everything works together. Let's smooth out the other end of the label now. Head back to the Templates menu so we can adjust the robot to move in the positive X direction. and insert another force command. Select the frame mode again. We need to apply force in the negative direction on the z-axis again. Set the z-force to -2. Good. Then take the RY checkbox to configure the gear. We need the edge of the other end to press down. This means we need a rotational force in the negative or counterclockwise direction. Set the torque to -1. Then select the empty node below the force command and insert a direction command from the basic menu. The robot is set to move in the positive X direction. Next, set the condition for when this movement should stop in the Until node in the program tree. Select the distance option again. Set it to move 150 millimeters. And that's all. You've successfully set up and programmed the robot. Great job!